All right, boys and girls, welcome back for a quick little 5-minute lesson on the most important theorem ever. What is that? The Pythagorean theorem. Okay, so important that they base an entire course on it called trigonometry, which has now been turned into pre-calc. Okay, but literally all based on this Pythagorean theorem. From the Pythagorean theorem, we will eventually get to SOHCAHTOA, which is sine, cosine, and tangent. You will get to the law of sines, and you will get to the law of cosines. These topics are the foundations of pre-calculus, okay? So you will learn this again in pre-calculus, and therefore it is absolutely in your best interest to understand it to the best of your ability, and then bring that knowledge along with you. It'll make your future classes so much easier. So here is the basic Pythagorean theorem. If you have a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. Typically, people remember that as a squared plus b squared equals c squared. But it's important that you recognize that what side does c represent? The hypotenuse, the biggest side. Okay, it has to. The converse just uses the Pythagorean theorem to prove that a triangle is a right triangle. So notice the order. If something's a right triangle, then a squared plus b squared equals c squared. And then the converse says if a squared plus b squared equals c squared, then it's a right triangle. In other geometry books, they'll teach you that if a squared plus b squared is bigger than c squared, then you have not enough hypotenuse, and that will be an acute triangle. If a squared plus b squared is less than c squared, then you're going to have an obtuse triangle. Okay, now I wanted to do a quick review of simplifying radicals. Does anybody recognize these numbers that I'm writing on the board right now? They are indeed the perfect squares. Very good. You're going to either want to know all of those, or for the time being, you're going to want to write those on the side of your paper. Okay? If you come across something that says this, an accelerated level, they want you to get the answer exact without having any perfect squares left underneath the radicand, the radical sign. So can anyone identify one of these numbers? The biggest one would be best. That goes into 162. Very good, Hallie. 81. So we can consider 162 to be 81 times 2. Does everybody agree? And then remember, we can multiply numbers in any order we want. So instead of doing the square root of 81 times the square root of 2, we can do the square root of 81 first. What is the square root of 81? 9. It's 9. So this is best written as 9 radical 2. And that's how you'll be expected to write your answers for full credit in my class. Any questions on that? Okay. Now we're going to take a look at special right triangles. Landon, come on in.
Oh, I was just going to ask you a grade question, but you're teaching right now.
Yeah,
so
I'll be done in like 3 minutes. Just hang tight, okay?
Yeah.
All right, so we've got 2 special right triangles. This, if you've ever seen an older sibling use a unit circle, this is where the unit circle comes from, okay? Look, there's a really good way to remember this. How many different sides are there on a 45, 45, 90 triangle? How many different sides are there? There's only 2 different sides. 1, radical 2. That's all you got to remember. Okay? What if this was a 10? Then what would this one be? It would be a 10 because these are both 45-degree angles. And so then what would this one be? 10 radical 2. That's it. It's as easy as 1 radical 2. Okay? If you can remember that, then this one's pretty much just as easy. How many different sides are there on a 30, 60, 90 triangle? There's 3. So first you have to identify what side is the small leg. Is the small leg the left side or the bottom on this triangle? It's the left because it's across from the smaller angle. So once you've identified that, that's your 1. What's bigger, 2 or the square root of 3? What number is bigger? 2 is bigger. So if you can remember that, it's as easy as 1, 2, 3. Okay? What if this one was 10? Then what would this one be? This one would be 20, and this one would be 10 radical 3. So they're just all similar. Do you understand now why we learned the similar triangles before we learned this? Okay? All right. Boink. Oh, made the same mistake again. All right, so now what do we do if we have a radical in the denominator? So what if we had this? What type of triangle is that? 45, 45, 90. Okay, now I'm going to sketch my little memory one. This one is 1, 1, radical 2. So how do I get from the leg, what do I multiply by to get the hypotenuse? I multiply by radical 2, right? So then what am I going to divide by to get from the hypotenuse to the leg? You're going to divide by radical 2. So this would be 20 over radical 2. And this would also be 20 over radical 2. Okay? Problem is you're not allowed writing numbers like that. So that's a new rule for you guys. No writing radicals on the denominator. So we have to change the way it looks. What's the only number we're allowed to multiply by in math that doesn't change the value of something? 1. So we have to multiply by a fancy form of 1. Now what on the top? 20 times radical 2? That's just 20 radical 2. But what's radical 2 times radical 2? If you said radical 4, you'd be smart. That's right, but we don't say it's radical 4. What's the square root of 4? It's 2. And then what's 20 divided by 2? 10 radical 2. So that's the right way to write these sides. 10 radical 2. That's the same thing. It's hard for some people to believe, but these are the exact same number. And if you don't believe me, let's try something. How would you get from your leg to your hypotenuse in a 45, 45, 90 triangle? You'd multiply by what? Radical 2. And what's 10 radical 2 times radical 2? That's 10 radical 4. But what's the square root of 4? 20. Sweet. It works. Okay? This is what's dangerous. The Pythagorean theorem is review, but I think all the rest of this stuff is new. So you've got to kind of lock in. Thanks for paying attention. Boom!